Hello, and welcome to the next episode of Creating Virtual Machine and Speaking in English. So this time it's going to be a little more organized because I've prepared a little to-do list, as you can see. Plus I implemented tests already for Lexer, a couple of tests, so we can today focus on implementation, not on tests. So yeah, and another change since the last video, the last stream, is that I changed general purpose registers from 64 to 16 because I'm going to create an enum for all these registers, so I didn't want to create enum with 64 values, but so I think 16 is okay for now. If it's going to be if we are going to struggle with to if we are going to need more registers, general purpose registers, we'll just create them on the fly. So yeah, let's go. So the first, so we have tests for the Lexer, and now let's implement the Lexer. As you can see, now it is not compiling because the G-test is trying to compare tokens in here. Yeah, because we have expect that tokens that we got from Lexer are equal. Tokens are just std vector of tokens. Yeah, Lexer lex returns std vector of tokens, and we call expect and we try to compare tokens to expected tokens, which are got from the parameterized test state from this struct, from here, which is also, of course, vector of tokens. So now what we need to do is to create a comparison operator in the token, and we are going to do this right now. Operator token this. Let's not bother with creating a SPP file for this for now. Let's just implement this. So I think that comparing token type is not sufficient because, for example, we have token types which is number, and we also we have to compare the number itself. So first, what we are going to do is compare, of course, the type. Type, and compare, of course, strings. str. We could use std_tie here, but I think it would just the code like that is more readable. Of course, let's create since we are here the not equal operator. Yep, and let's try to compile. Shit, we have a lot of warnings. Okay, so first warnings from Lexer, but we are going to implement the Lexer, so not bother. But I instantiate test case P is deprecated. Let's use the suggestion. So is it going to work out of the box or not? I hope so. Yep. And now let's try to run that. Why don't we don't have failing tests? Okay, we have failing tests. Yep, so one test is passing and guy skips white space. White spaces is is yeah, it has sex fault. It has sex fault. So let's see what's going on here. Of course it has sec fault because I don't know why. But yeah, let's implement the lexer and we'll see. So the lexer lex is calling get next token, which is switching from the next character. And okay, when we have one character token, we just call get one get one card token, which just returns that. Cool. On default, let's just assert for now. Yep. Assert and unexpected. One character token. Cool. So switch is okay for now. Yeah, let's now just see whether let's just now handle the not one card tokens. First case. Yeah, so I think I'm going to change the case, switch case, because we are going to need to check whether the next character is, for example, character for identifier or character for number. So let's just change this to if else. Yeah, so yeah, let's create a new function. Is one car is okay, it's car for one token, one hard token. Or no, better. Is current one card token. Cool. And let's implement that. And we want to return true whether the current character is not at end. We are not at end, and the current character is one of these. So not is not at end. Is not at end, and const auto. Yeah, let's just. So we have comma here, open square, close square, and colon. And do we have algorithm here? No. So let's include them. And any of any of cars. And let's pass. I need to introduce Clang format here because manual formatting is not that good. Yeah, let's just car. How many of looks like? Forgot. Predicate takes predicate. Oh yeah, of course. So current character, and return whether the C that we get from parameter is equals to current, or better, the current equals to C. Cool. Okay, it looks okay, I think, at least for now. So let's not completely remove, but create an if is current one car token, return one car token. Else we can omit else because when we get to the if we return immediately, so yeah, let's just skip the else. So if is current, let's change this name. I don't like it because it should be current is current. Oh no, let's skip it. Okay, now let's implement function is current identifier token is current. Yeah, let's just be consistent. And identifiers starts with alpha, so I think there is an alpha. Is alpha? Of course it is. And it not cpp+com cpp reference for the win. So is alpha, checks whether rule. Cool, that is what we want. So we are going to just return whether the first first character in the next token is alpha. Yep, or it is underscore, because identifiers can actually start with the underscore. So yeah, return. Yeah, return. Is alpha. Or of course it's not at end. It's not at end. And is alpha, or I am current car. It should be better to create a function current that will dereference the mcar, but let's do it in a moment. Is equal to underscore. Yeah, let's just do it now. Current. Oh no. Yeah. Yeah, it's better. Okay, this. I wondered whether the creating another function method actually for just the referencing iterator is not overkill, but it's cleaner to read current call than the referencing some m car. So yeah, I'll keep it. I'll take it. And let's change everything. Okay, that's bad. Here, fuck. Okay, so here we have a trouble because current returns character and I don't want it to return reference, but we need to get reference to create a string view to actually create a token, a string view for token. So let's create another function, current reference, current ref that's going to actually return a reference to current character. And yeah, it also is going to be cleaner. Okay, current ref. Let's rename it to cref because that's a constant. Yep, refactoring for the win. Okay. So do we have yet? Here it is. Another one. Get one card token. Let's remove the parameter from here because we are in one class scope, so we can use current directly here. Okay. Okay, it looks okay. I'm going to create probably one more function to create tokens from string views from the source, but not now. Okay. So get next token if current one card token, get one card token is current the identifier token, return get identifier token. Okay. Now let's create this function. Const, it's not going to be const. So here we need to gather all characters that are part of the identifier. So let's get current iterator. Okay, current iterator, and now what's okay? And string view I think has cool function method is not one off, if I recall correctly. Yeah, find first, not off. Okay, but we don't have string here. We do have. Okay, with string it would be fairly easy because we just call this function method and yeah, and done. but we have only iterator, so let's create a predicate. Yeah. Okay, first characters that we accept, predicate that accept only. We already have that. Is current identifier token. Cool. So the predicate would be this. Oh shit. Yeah, let's capture it for now. Is current identifier token. Okay, and now we have begin when we want to search and end. So end would be just end. Yeah, we want to stop there. Okay, so end. Let's cool. We are going to find with the help of std find if character, actually iterator to character that does not fulfill this predicate. So we can't like negate the predicate that we pass to the find if, so we need to negate it, the predicate here. So let's find from begin to end character that for this character predicate going to will return false. So so this character is not going to fulfill its current identifier token. Cool. Easy. So we have found it. Let's now okay, so we want to get identifier token, and in found we have iterator to the character that where the identifier ends. So now let's create a string view for this token. Eating. Okay, I'm going to and string view is going to start at current iterator, of course, and its size is going to be std difference distance from begin to found. We don't care whether the found is end or not, because it is simply where the identifier ends. So yeah. What constant expression gonna be IKA unsigned in. Okay, so I think we can assume that it's going to be positive, so let's just static cast it to unsigned, or better size t. Or assigned, whatever. Oh, let's be good. String is as size type, so let's cast it to string view size type. Yeah. Okay, so we have string view for the token, and now now we need to skip that much tokens that we created. We need to eat tokens from current source, because After token creation, we want to go to next token and flex the source that is after these tokens. So, yep. So let's create a function eat that is going to eat, or let's add. Yeah, we want to eat more than one character. So let's eat and let's say and it's going to be one. Eat, where is it? N and N. Cool. So we want to eat here. We have string view for the token, so let's eat size that match characters from the source, from input. Now what is going to, yeah, and now just let's return the token, created token type. Token type is going to be identifier, of course. Why? Yeah, okay, doesn't matter for now. Cool. So get identifier token. Yeah, we have it. Now let's create getting numbers. So of course let's create is current number token and implement this. We are going to just return of course it's not is at end, it's not at end, and current is, oh no, is digit. Yep. And now if current is current number token, return get number token. And getting number token is quite similar to getting identifier token, because we are going to just iterate and check whether the predicate is fulfilled for current character. So I think, yeah, let's for now just copy this and see how it looks. Predicate and find if. Okay, predicate this digit. No. This current flag. Okay, that's not going to work. Is current identifier token. Okay, it's not going to work because for the whole iteration it's going to actually return true, because the current iterator stays at its place. So we need to change that. Okay, so we are going to have his current identifier token, but we are going to create another function method that checks whether the character, a past character is identifier character. And there we are going to check something like this. So okay, not sure why it didn't insert here character, but yeah. Let's see. We don't need to check whether we are attend. Cool. And in is current anchor token no. Here we are going to just check whether we are not at end and is identifier token current. And with that, in the predicate, we can check whether the is identifier car, the car that we got in the parameter. Yeah, that should work now. So let's copy correct version. And instead of checking is identifier, let's check is digit. See. Cool. And yeah, it looks very similar because so yeah, it looks very similar. Now let's number. So we can extract the similar part into one method that is going to accept probably predicate and actually only predicate. Okay, what we want to achieve? We want to achieve getting rid of the code duplication. So we need the expected token type that we want to create and predicate that we want to check on characters. So okay. Let's create another function, templated function, type name predicate. Yeah, pred is okay. It's going to return token and is going to be named get and it token for predicate. Token for predicate now. Oh yeah, let's fuck it. Get and it token for predicate. Cool. So we are going to accept token type. Type and predicate. Const? No, it's not going to be const. Okay, pred predicate, and it's going to look exactly like this. Instead of token fixed token type, we are going to pass here the type that we have from parameter, of course, that user wants, and we are going to pass predicate to find if. So get number token is going to just return. Okay, we need predicate. Token type as a number and predicate. That's easy, and it looks a lot better without the duplication. Okay, so predicate and not number, but identifier. Cool. Cool. Yep. It should work. Get number token. So we have get number token, get identifier, get one car token. What do we need now? Oh yeah, we need to skip white spaces, because source code often has white spaces. So actually, where do we want to skip white spaces? Let's now check whether this compiles. Cool. Okay. So we have legs and we go while we are not at end, and we get next token, and this would be better to in place the token to the tokens. In place back. Cool. Yep, so we got new token and we in place that token. White spaces can be before every token, let's assume, because we can have white spaces at the beginning of the source code, the end of source code, and of course between the tokens. So let's keep white spaces here, but it introduces another problem, because when we keep some white spaces, for example, we have source code, and at the end we have white spaces, so we skip those white spaces. But then we actually don't have any token, because there's no token after white spaces at the end of the file. For example, we have a new line at the end of the file. So that would be... So that means we actually get next token can... No, let's keep it simple. Get next token is going to always return token. Let's assume that. We are going to skip white spaces here in the while. So in the while, let's create another function. Keep white spaces or eat white spaces. White spaces. Yep. Yeah, I like to have those functions, similar functions, near each other. So yeah, how do we do that? We could do while, but we can also do something like finding here with predicate. So yeah, current is going to be yes predicate, but not predicate is going to be card C. Return. So the the white spaces. We want to find first character that is not white space. So we are going to return whether it is not. Std is white space. There's no function is white space. Oh shit. Oh, yeah. Okay, I overestimated Google. Yeah, of course, is space. See. Okay. So we have predicate, we have find if, we had found, and we are going to the end. And what do we want? We want to eat all those white spaces. So let's just if let's calculate how many white spaces do we have. Cut, no. Is equal distance from begin to found. And when we have more than if we have any white spaces, let's just eat them. Yep. Cool. So in while, let's just call it white spaces. And now if we are at end, let's just break and return tokens. And if we are not at end, let's get next token and let's go for another iteration. Cool, cool. Now let's try to run those tests that we have. As you remember, yep, white spaces tests. White spaces tests failed. I was failing, and it still fails. What do we have here? Okay, let's. I don't like this. Okay, first let's create a commit. Identifier token and get number token, and let's keep it like this. So test fails now, and yeah, as you can see, it fails with rather ugly output. So let's create operator here. So std ostream, we're going to return reference to ostream operator and that gets ostream out and const token, token. Cool, and we are going to return for now just out. Okay, let's format it like this, that we are going to have square in square brackets, square parentheses. I don't know if I say it correctly. Whatever. And the token ID, token type actually. Type. Yes. And after type. After type. Let's just output tokens str. Cool, and it should help. It's going to compile here. Yep, cool. So yeah, okay, whatever. I don't like the two commas, but yeah, whatever. Okay, so the skip white spaces files with such output expected is move, comma, open R10. We have strange things here. Okay, F10. Okay, yeah. So let's just debug that. What do we have in tokens? We have one token. Okay, that's not where I wanted. Breakpoint. I wanted it here. And in tokens we have something strange. Why this shit is okay. One more time. Let's actually debug it. Eat white spaces. Okay, is at end no, get next token. So yeah, the input is two spaces and now move. So yeah, let's get identifier token. Predicate is this. Okay, begin is M, which is good. Found is this, cool. So str is move, also cool. And now let's return type. Type is of course okay, it's okay. So tokens is looks okay for now. So yeah, apparently, okay, let's return. And what do you... Why? Tokens. What are tokens now? Why? Again. Okay, so apparently tokens are messed up when returning. Why? I don't know. Okay, source, let's begins the end. Of course. It. Yeah, so the problem is that here source is not std string that lives for the whole lecture, for the whole test lifetime. Actually, we have constcar here, pointer. So constcar pointer, and here we create a temporary std string that is bound to the parameter. In parameter we get source. Yeah, we just get the iterators to temporary string, and yeah, and we have kaboom. So now let's create actually std string from this. So now we have a std string that lives for the whole lifetime of the test, and we can assume that tokens, that string views in tokens also lives. Don't point to some deleted string from temporary string. And it still doesn't work, but it's better. It's a lot better. Okay, identifier. Ah, yeah. So yeah, the problem is that R10, the register, is splitted to two tokens, R and the number token 10, because the predicate is written in such way. So let's fix it. So yeah, get identifier token, and in identifier token we want to Okay, so we basically want also to accept here digits, because when we are in this method, we already know that we want to extract token that is identifier, so the current token is not digit, so it means that we can assume that current token is like underscore or some letter. So yeah, let's do a quick fix here. And is not digit. Yeah. I'll take that. I'll take that for now. What do we have here? Is alpha in? Yeah, it's okay. Fixed. Let's just create a quick commit for the fixing white spaces test. Where is here? Okay. And yeah, let's see what else now. Expected actual. Okay. Cool. Cool. Another commit. Atomic commits for the win. I don't. Yeah. Let's not refer to the test like that. So fixed. Okay. So yeah, we do have now quite a working Lexer. Of course, we don't like handle all errors, so we are going. I think we are not going to implement that now because that's actually boring. Yeah, let's see What do we have in the to-do? Lexer, cool. Parser. Yes, I think we are going to move to parser now. So, yep. Parser. So, we have Elixir that returns vector of tokens. And now we want to pass those tokens to the parser that is going to actually return vector of opcodes for our machine. So yes, let's do that now. So let's create a new class, parser, of course. Let's fix the mixes. Shade, because when I create, okay, let's fix it. When I add a new class or something to in CLion, yes, it adds the sources to the CMake, but it adds it in such a weird way. Not sure why. Let's move them to the lib. Okay, so parser, pragma1, school, lexer, let's copy that. Yep. Okay, so parser, public. It is going to return opcodes. So it is going to return a vector of something. Yes. Include the vector. Okay. It's going to have one public method. Parse. Okay, let's make it const for now. It's going to accept tokens. So yeah, let's include tokens here. Token vector token of tokens. Cool, and like it in Lexer, let's create a private generators. So current and okay, tokens opcodes. I'm thinking how I can, let's say, encode the opcodes, because in my architecture I want every memory cell and every like basic unit in the architecture is going to be unsigned int 64. So yeah, let's just not bother, and for now we are going to probably change it to some enum, I suppose. But yeah. So parse, let's implement the constructor. No, yes, I don't want it like this. Yeah, that's better. So parser current going to be token. See begin of tokens. Shit, I really need the Clang format here. And going to be, of course, cent tokens. Yep. And now parse. What's wrong? Parse method. So as usual, let's create a result vector. And create a result. And let's create straightforward whale. For all tokens. Okay, and now, so what are opcodes and what are actually tokens? So tokens are, let's say we have some instruction. Okay, let's say we have something like move this, move, let's say, to R1, R2. So we have 4 tokens here. First one is of course move. The second one is identifier R1. Then we have comma and R2. And so we need to interpret such instructions and translate them into opcodes. So the architecture we can see, not in the architecture, in opcodes we can see that we have not just one instruction move, but at this moment 3 move instructions. Moving register to register, moving something from memory to register, and moving something from register to memory. And similar to add, sub, and stuff like that, and go on and go on. So, for example, the first opcode would be identifier for actual instructions, and then arguments. So for example, move register RB to RA would be opcode. First opcode would be move register to register. Next opcode would say which register we want to move, and next opcode would say okay, first move register to register, second opcode to which register we want to move, and the third and the last one for this instruction would be which register we want to move. So such thing, let's say move register to register would be move reg. Next opcode would be, it's fairly simple, would be RA, and the third one RB. And such opcodes are going to lay in the memory and in let's say file system. The disks would lay. Okay, such opcodes are going to lay as simple numbers in the disk. So let's say move rec2 is going to be represented by, I don't know, 0 number, RA is going to be represented by, I don't know, another 0, and RB is going to be represented by not 0 but 1, because we want to distinguish those registers. So then interpreter or executor is going to read first opcode, so it reads 0 and it knows that it is about to move one register to another register. Then it's going to read two next opcodes, which are the registers. Simple as that. The only thing, it's going to be quite boring, I think, because we need to create all opcodes for all these instructions and opcodes for all registers. So, but yeah, we have to do this. Sorry. So let's go. So I think right now we have 3 move methods. But yeah, okay, no, blah blah blah. Let's now create an enum, which is going to be in header file, and this enum is going to contain opcodes for instructions. So opcode. Oh, I have high voice today. Yep, and the enum instruction opcode. And like I said, okay, so where are opcodes? Let's split. Okay, we don't need the view right now. Oh. Okay, and now we want to create an opcode for each such move. So we create move register to register move. Okay, and by move reg I mean that I want to have move with 2 operators, register and register. Then I want to have move with register and memory. Then I want to have another one with move with memory and register, and so on and so on. And what I want to okay, I'm wondering, because let's say that I compiled some program a while ago and then I create a new instruction for move, and so I compile program with such with such opcodes, add reg, and then so I have opcodes and in binary mode for the program that I compiled, but I added some crazy move. So actually the opcodes are moved by 1 forward, because now this has index 3 and not the add. So the program that I compiled a while ago on the new version of architecture is going to probably crash. Shit, I'm going to have crashes in my architecture. But yeah, anyway, I'm just wondering, because I want to, let's say, reserve. I want to have backward compatibility for a while, I think, at least. So every such instruction is going to have, let's say, like 10 reserved opcodes. So move is going to start from 0, add is going to start from 10 or 20. It casts, or 10, yeah. Okay, so add regreg, add reg, mem, add reg, not mem reg. Now sub reg going to start from 20. Sub reg memory. Sub reg. Okay, let's copy that. Multiply. Yeah. Diff is same. Starting from 40. Div. And div. Next, ink. 50. Increment has only one argument, which is register or memory cell. And memory. Cool, and that. Yep, 60. Compare is going to look almost exactly like the other ones. Compares CMP, jump is quite easy. Yeah, but I will still be consistent with the starting values. So jump, traction pointer. Yeah, let's just say jump. Jump equal 90. Jump equal, jump less, jump greater, 100 to 110. Okay. We do have instruction opcode. Let's add this spelling. Okay. It is instruction opcode. Now let's create another enum with registers opcodes. So architecture. Register opcode. Let's just copy that. And in registers, I think I don't need that much. I don't think starting values, because let's just start with the rip and a rem. So yeah, red, rip, a rem, and starting from here, let's create this. Eight, 9, 10, and 250. Cool, 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 cool. Okay. Yeah. Simple commit. Introduced registers opcodes. Okay, flags. Actually, flags are not going to be represented in opcodes because those are only implementation details of compare and jumping. So let's keep them. Now let's go to the parser. So let's stick with move right now. Yeah, I shouldn't have closed the opcodes. Parser. So we have move. And now we have for example tokens for move, and now we need to let's say okay, let's just go with it. So the opcodes get next opcode. Yeah, let's create this function. And I'm going to okay, for now. Yeah, shit. I didn't know what to say. I mean, I was thinking. So, yeah. What I wanted to say is that we want to create. We don't know how many opcodes the instruction takes at this point, at the point of here of this while, because like I said, move has like 3 opcodes, which is instruction and 2 operands, and inc has 1 opcode, jump has 2 opcodes, similar to deck and jumps. So we need to have to the opcodes count may vary. So for now, let's just return vector. But as you know, we are going to have a lot of memory allocations with such vectors. So for now, let's stick with vector, and then let's create some. If the performance is really bad, let's create the small vector implementation or so to just do not bother the heap, but keep everything on stack. Yeah, but for now, vector of units. I probably should move this some alias, common alias, because unit is kind of important in the architecture. But yeah, parse. Get next opcodes. Okay. Let's now create current. And now in getNext opcodes, let's create a naive implementation of getting move, and then we are going to see what can be improved there. So yeah, if current if current string is equal to move, why is not operator? I don't need to call it, just a member. Okay, if string of this opcode is of this token is move, we need to handle 3 cases. So now we need to eat something void eat. Let's now not bother about how many tokens we want to eat. Let's just eat advance current, yeah, 1, not 1. 1 is in Polish. So so if we have move, let's eat. Now let's see whether we have register or square bracket. So let's create another function is current register, and current is register. Okay, and we have such registers. Let's just create a naive implementation rex r0. It's going to be ugly. Okay. Yep. This current register. So let's return std any of any of. We need to create a predicate there. So okay, it's a shame that initializer list does not have contains method as well as other containers. So let's create a contains for now, because we are going to need this, I think. Okay, let's not bother. std find. No. begin rex reg registers, and we want to find current string. Okay. And we want to return whether we found so let's iterate through rex and see whether current string view is equal to any of them and return that. Okay, is current register register, let's eat this register, and now we need to check whether the okay, we need to eat the comma, so let's eat comma and now we need to check whether the next operand is register or memory cell. So another if current register, we have register reg2, let's eat it at this point, and let's return the opcodes. So right now we do have opcodes for move, we don't have opcodes for registers, so let's create a function that translates register from string view to register opcode. I think it's going to be best. Okay, register opcode is going to be used across whole virtual machine, and actually I don't need this function here, so let's create this function only in the parser. So token, let's forward declare the register opcode. Cool, and let's create register opcode string to register. Yeah, not const auto, but string view. Cool. Here, let's create a map. Yeah, I think it's going to be a map, but it's ugly. Maybe it would be better to, for example, because what's the best way? We could create such regs initialization list and then find string view here and then create calculate the distance from begin, and that would be integer representation of the register. Then we would need to ask this to register opcode. That's ugly. Another approach would be to parse the string view, but that's also ugly because what when I somehow change the register strings. So yeah, let's just create an ordered static unordered map here. Unordered map of okay, map of string views. Let's see whether we have it here. I mean, okay. Yes. String view to register opcode. Okay, it looks like that it works. So static const is equal to, and here let's have R0 to, and that's why I didn't want to create 64 registers. Okay, 0, 1. I'm good with only 15. Cool. Uh, 16, not 15. Okay, so now we do have the map. Actually, let's create this map as a static member of the parser, so we could reuse it in the isCurrent register and get rid of this ugly thing. So yeah, static const registers. We need an unordered map here. Cool. And let's create it somewhere above. Parser. I think it should work. So now instead of this, we can actually return I'm current find. No, I'm current. Registers find is current register str is not equal to stds and of registers. Cool. And here it's fairly simple because we just need to look up in the map. So find is equal to this. That's string. Okay. And now opcode. Let's add another opcode here, which is going to be unknown or undef. Or we could return from here an optional. Yep. Optional. Optional is okay for such purpose. So let's remove the undef opcode. Cool. So we have found if STDC and rem registers. Let's remove null opt. If not, okay, it's better. Let's use the operator. Okay, easy. If it's okay, if we found something, let's return that. Second, and if not, let's return null opt. Is it going to work? Of course not. Okay, so yeah. If we didn't find anything, let's return null opt, and in any other case, let's return what we found. Okay, str to reg works. Const auto reg opcode. Start to reg, and now register reg opcode. Cool. Okay, let's check here whether the first register is actually a register and that we know. So if it's not, if the register is not found there, let's raise an error. Plus the string. Okay, let's create a this function. Raise error. With the message. And for now, let's just output it. Yep. CDC out and message. And the new line. So get next opcodes should also return, or okay, let's assume that get next opcodes is going to return empty vector on error. Okay. Now let's do the same with the another register. Rec2 rec opcode rec2 opcode if not rec2 opcode. Cool. We do now have some opcodes checking. Registers checking. Cool. So now we have move register to register, and now let's return the opcodes. Comma is hidden, yes. So now let's return std vector. Let's create an alias for the opcodes. More convenient than typing std vector everywhere. Here. And let's return the opcodes. So now register instruction opcode. Move rec. Next one is rec1 opcode and rec2 opcode. And now it fails because we can't create opcodes from enums. So let's go here and say explicitly that we want unsigned int 4 and include cstd int, and let's go also here and let's say it also. Yep. What's the matter? Okay, we forward declared the register opcode. std unsigned int, let's std here. And now it is it happy? Of course not. Okay. Let's create a function, template function that accepts some enums, some opcodes, okay, no, opcodes, and returns opcodes, and it's called make opcodes. So thanks to that, we can create opcodes in a convenient way, which is just returning opcodes with our opcodes static casted to unsigned int 64. Okay, Ta-dam! And here we can just call make opcodes and pass the opcodes there. Any opcodes. Ta-dam! Cool. Cool. I'll say cool in a weird way. Okay, okay. So now, okay, we have move reg. Now let's handle the move reg from memory. So if current is register, then we know. If not, then we know that current is memory. So let's eat open square. And now, of course, let's eat close square here at the end. Here, let's eat pointer in memory. Current. And let's eat it. Now, let's assume that the pointer is actually a number. So, we need to convert the number into the number into the opcode, which is quite simple because we just need to create just convert the string to an integer. So let's do this. That is token mem pointer is equal to std string to hindsight long token str. Please accept this. Back. String view to int from cars. Okay, so we have from cars that returns structure from cars result. Cool. Let's use it. So we have mem pointer const. Okay, and we have mem pointer token and mem pointer token. It gets a little ugly. But yeah. Mem pointer string equal string. Okay, let's say this up a little from cars. Where is that? Okay, it's here. From cars. Oh, you don't work. Anyway, okay, result result. What is result? The reference. It's supposed to be a reference. Okay. Ugh. I need some sleep. A result. Why you don't want to from cars? I don't remember the version of Clank, but only in integer, but I do have Clank. Okay, let's see. Yes, I do have Clank. 7. Clank 7. Okay, let's not bother. Okay, okay. Next is prettier. Why not data and okay, result. Okay, so we have so it returns pointer where it stopped and error code. So we don't need the pointer, but we do need the error code. So now if error code is not equal fault error code, we do have problem because we need to report that. Malformed number. Okay. If everything went okay, we have the memory pointer here. So let's just return yeah, let's eat and return opcodes. Which is reg mem and mem pointer bang. It looks fine, but from cars it's not going to car. That's not good. Okay, anyway, I think we are going to stop here. Meantime, before the next stream, I'm going to resolve the from cars problem and just yeah, and see what and say what was wrong with this in the next stream. Because as you can see, we have quite a big if for the just handling the move, and we have a lot more instructions to handle. So we are going to implement this in slightly better way, I think. If I will be able to figure one out, a better way out. So yeah, thanks for watching. No one. Anyway, yeah, bye. Yeah. Where is the